So the first thing in our sensation and perception unit we talked about was sensation and perception. So sensation is the way we receive information through our senses. So what that means is that when we have our senses, so we have our eyes, our ears, our mouth, our nose, so all our senses like our taste, our smell, our sight, things like that. So it's the way that we receive the information through our senses. That is what sensation is. We then have perception, and that is the way that we interpret this information that we're receiving from our senses. So our sensations is how we are receiving the information, so the way that we receive it. And the perception is how we are interpreting that information. We then have a few other things we need to know. So we have the word transduction. So this is the process of converting our energy from a stimulus into our neural energy. So when we look at something with our eyes, we receive that energy from our eyes, and then transduction is the process that converts that to neural energy in our brain, and we can understand what we're seeing. We have what's called sensory adaptation. So this is a constant level of stimulus results in a decreased response over time. So with constant and continued exposure, the neural response to the stimulus may change over time. So if you're in your grandparents' house and they're baking bread, and when you first walk into their house, you smell lots of lovely fresh bread. Once you're there for about an hour or two, eventually you can't smell the bread anymore because your senses have adapted to that smell. If you walk outside, do something for about a couple minutes and walk back in, you should be able to smell that bread again because your senses are not adapted to that smell anymore after you have left it. The same thing can go for your eyes. When you're sleeping at nighttime, your eyes are closed and everything's dark. And as soon as you open them in the morning, or you should open the curtain in the morning, the bright light comes in, your eyes will have to adapt to that sunlight eventually. We then have two different types of processing. So we have top-down processing and bottom-up processing. So top-down processing uses the knowledge that we already know about something to interpret what we are seeing or what we are viewing or what our senses are getting in the information. Versus bottom-up processing is that we analyze the information that we are currently have, and then we form new knowledge about it. Okay, so it's brain-centered stuff. So from our brain, all the knowledge we know, and then we use it to understand what we're seeing. This one here is a receptor to your brain center, so things that we're seeing or viewing or hearing or touching, we then make new information into our brain center. Okay, so top-down processing and bottom-up processing. We then have what's called thresholds. So we have an absolute threshold and a difference threshold. The absolute threshold is the point at which a stimulus can be detected. So it's like the very point at which that we can detect a stimulus. So I think a few examples of that was letters were getting bigger and bigger and bigger. So the point at which you can detect the bigger and bigger and bigger of the letters is the absolute threshold. If you have different shades of the color pink and it's like a lighter pink and it's moving on towards a very dark pink, the point at which you notice that these colors are changing to a different shade of pink is the absolute threshold. The difference threshold is the smallest difference between two stimulus that can be recognized. So I think an example of this was when we put a drop of perfume or you spray perfume in your house. You can smell it usually throughout the whole house, even though it's one spray of perfume goes a really long way. So that's the difference threshold. So it's the smallest amount of some stimulus that you can put into something and it can be recognized. So another example here says turning down the stereo volume, you may hear a difference, but your sister may not. So that is the difference, the absolute threshold. So you notice the difference, but she didn't notice the difference. If you can hear the difference, it exceeds your threshold. If she can't, it does not exceed hers. Two last things we have on here, we have a just noticeable difference. That is the minimum amount of change in a signal that is still recognizable. So an example is how many lights must be turned off before you notice the difference. So if you have a bunch of different lights in your house and you turn one off, you may not notice, but you turn off the one right above you may notice that. So that is your just noticeable difference. And then the last one we have down there is our signal detection theory. So this is distinguishing sensory stimuli that takes into account the setting, physical state, the mood, and expectations. So I think the example of this we used a lot was if you constantly hear a baby crying, because you have a baby at home and you go out in public, you might be able to detect a baby crying far away because your senses are adapted to hearing and noticing when that baby's crying. Another one might be if you are expecting someone to come visit your house and you hear a car slam next door, you might go out to see if your friend or the person you're expecting is here, and it may not be them because it was the car next door. But you are looking out for that car slam, so that is your signal detection theory.